What are the most mind-blowing facts about the deep space? While NASA catalogs all the asteroids in the asteroid belt, they don't actually take them into account when firing probes and such through it because it's so spaced out that there's a very low chance of them actually hitting the probe. Densely packed asteroid fields where you'd have to dodge and weave through them are pretty much sci-fi. Technically there is at least one real one in our solar system, the rings of Saturn. Mankind has reached 20 billion miles beyond the Earth but only 7.5 miles inside it. It's easier to drive through a vacuum than it is to drive through a brick wall factory. To scale, the Sun is the size of an atom, Alpha Centauri, the closest star, is 1 millimeter away, our galaxy, Milky Way is 15 meters, 50 featuring across, Andromeda Galaxy is 360 meters, 3 football fields, away, the observable universe is the size of the Earth, it takes light 4 years to travel 1 millimeter, 100 years to travel 1 inch. This made me bizarrely happy, thank you. The Milky Way, the galaxy in which our solar system resides, is home to at least 100 billion other planets, and up to 400 billion stars. The Milky Way is just one of 100-200 billion galaxies in the observable sky. The concept of voids has always been mind-bending to me. For those who aren't familiar, our universe is basically formed of galactic groupings called clusters and filaments, depending on whether they are groupings or long strands. Voids are the space in between these groupings, and are essentially massive zones of near total nothingness, with something like 10 times fewer particles than even interstellar space. Crap's wild. There's a void that's so large that if our solar system was at the middle, we wouldn't have known that other stars existed until we had 1960s level technology. The coldest temperature in the known universe was created in a lab here on Earth. And the hottest, as well, though it was only for a fraction of a millisecond inside a particle accelerator. A lot of people already know that if the sun suddenly disappeared, we'd get its light for 8 minutes, but fun fact, we'd also get its gravity for 8 minutes. If we could drive straight up, a drive to outer space would only take about 2 hours. To the moon is a 6-month drive, and Mars would be 228 years. If you snap a piece of metal in half in the vacuum of space, it will weld itself back together seamlessly if you rejoin the pieces. The only thing that stops it from happening on Earth is because we have a pesky oxygen-rich atmosphere that ruins everything cool. Except fire. Fire is cool. This blows my dang mind. My absolute favorite space fact are the wacky orbital parameters of Venus. It takes Venus longer to rotate once around its own axis, i.e. a day, than it does to orbit once around the sun, i.e. a year. Imagine trying to make a calendar for living on that planet. Your boss at the Venus Corporation, I need this done by next year, damn it, not tomorrow. That as far as we know, Mars is the only planet entirely populated by robots. And Venus, technically, we've sent a couple probes there, they just didn't last very long. I'll bungle the details, but that a man-made object, Voyager, has left our solar system, has gone billions of kilometers away, and that we are able to receive info from it via radio waves. This truly boggles my mind, that we can receive a message from that far away. I think someone pointed out that it's largely because space is mostly empty. We can receive messages from a satellite literally billions of km away, but I still get 200 ping to a server literally 100 miles away from me. God damn it, Comcast. Hold up your hands and clap them together. Wait 1 second, then do it again. If you could plot the distance between the first clap and the second clap, it would be more than 800 kilometers. This is because the Earth is moving around the sun. The sun is moving around the center of the galaxy is moving through the Virgo supercluster, and the Virgo supercluster is barreling through the universe. When you add up all the velocities and compare the result to the cosmic microwave background, which is the closest thing we have to a universal frame of reference, it comes out to about 800 kilometers per second. Sit still for an hour, and you'll travel farther than you'll ever walk in your life. TLDR. Zoom. If you're barreling across the universe and you know it, clap your hands. A supernova is brighter than you can comprehend. If you were to take a nuclear bomb, Hold it up to your eyeball and set it off. This would be incredibly bright for that picosecond before it killed you. But if the sun were to go supernova, it would be a million times brighter than that, even though it's 93 million miles away. Supernovae can outshine their entire galaxy. In theory, if we could place a mirror focused on Earth 0.5 ly away and look at it with a telescope, we could see events 1 year in the past in real time. Jupiter is so massive it doesn't technically orbit the sun. Its barycenter lies 1.07 solar radii from the middle of the sun, or 7% of a sun radius above the sun's surface. Both the sun and Jupiter orbit around that point in space. Bonus fun fact, this is how we first started to identify which stars had large Jovian-type planets orbiting them. Measure the wobble as the star and its unseen offspring orbit a common point. There's a famous quote from Heinlein, once you're in low Earth orbit you're halfway to anywhere. Now obviously this isn't literally true, but it's closer to the truth than you might realize. Using Hohmann transfer orbits you can get from one orbit to another, say from Earth to Mars, for a very low delta V expenditure compared to the delta V required to get into orbit in the first place. The downside of this method is that it's slow and you have to use a specific launch window to get there. For example, to go from Earth to Mars this way the launch window occurs every 26 months and the journey takes 9 months. I've played Kerbal Space Program and this is entirely true. That there are supermassive black holes bigger than our solar system. If you entered a black hole then you'd be able to see the back of your own head. Also scientists think that a couple seconds in a black hole could equal years on Earth. And an eternity in heck, thanks to spaghettification. If you nut in space you move backwards. TBH I think I moved down and slightly to the right. There are whole, I think nebula, made of alcohol. Yes, but they're mostly composed of methyl alcohol, not ethyl, the drinkable kind. If you leave enough hydrogen long enough, it'll begin to wonder why it is there. We are the universe experiencing itself. The epitome of science meeting philosophy. Women don't need bras in space. If you were to put a woman naked in space, in just a few minutes she will never need a bra again. Amazing. The asteroid belt does not look like Star Wars. You could be on an asteroid in the middle of the belt and chances are slim to none you will see a neighboring asteroid with the naked eye. Less than 5% of the universe is made up of regular matter that we interact with and are made of. More than 95% of everything that exists is considered dark energy or dark matter. Basically, things we can't see and don't fully understand. Essentially, the universe is 5% tangible stuff and 95% empty energy fields, cosmic forces etc. Also, if we took all the regular matter in the universe and compressed it to the density of a neutron star, densest thing we know about in the universe, other than our mom, and placed that compressed ball where the sun is, then it would only reach to between Mars and Jupiter. That deep space is so far away that if we, humanity, ever tried to go there, by the time we got there, we'd have already been there, colonized it, and possibly gone extinct there. Imagine you're a pioneer. You're the first person ever who is about to move from the east coast to the west coast. You set out on a journey that's going to take 10 years by horse and carriage, moving very slowly with a family. 1 year into the trip cars are invented, and so another family sets out and makes it to California in 1 week. By the time you show up, Family B has already been living in California for nearly 9 years. Take that scenario and apply it to space. I'm blanking on the name of the theory, but essentially it says that if we tried to travel anywhere of great distance, technology advances too fast for a faster means of transportation to not be invented before we get there, so someone would always arrive before us. Water facts in space. Ganymede, Europa, and Callisto are thought to have subsurface oceans larger than all the bodies of water on Earth put together, but not all together individually. This is because water tends to aggregate in the outer part of solar systems while they're forming. Celestial bodies out there might have formed with as much as 50% water ice by mass. Water is soluble in magma, so most water would be trapped in the mantle. As the mantle cooled, water is exsolved, but unlike Earth, which is close enough to the sun to maintain liquid water on the surface, these moons are past the frost line. Water on their surface froze. but tidal flexing and the heat from their cores caused massive subsurface oceans to form. One possible exoplanet type is the ocean planet, sometimes referred to as a pine-thalassic planet. Such planets would actually have a harder time developing life than Earth. Oceans on Earth extend down around 11 kilometers at the deepest point. On a panthalassic planet they could extend down hundreds of kilometers. At such depths, even at high temperatures, the pressure would still cause massive layers of ice to form, ice that might not even be cold. This would make the travel of important nutrients, like phosphorus, to the water nearly impossible. On Earth, these nutrients mostly come from runoff from the land, which would be impossible on an ocean planet. Such planets would have atmospheres thick with water vapor, which would cause a strong greenhouse effect. If they were large enough to trap hydrogen and helium, they would in effect become warmer ice giants, like Neptune or Uranus. In a couple years, hopefully, fingers crossed, we'll be launching the James Webb Space Telescope, the successor to the Hubble. Is going to be 1.5 million km away from Earth, somewhere called L2, which is beyond the moon itself. It will be able to see far enough to technically see the universe early after the Big Bang. Oh, and we recently landed a tiny module onto an asteroid only 1 kilometer wide, and it's planned to return back to Earth with rock samples sometime next year. Apparently we've already done this around 2005, FKA nuts. We don't actually know that the Big Bang was the start of everything. We just don't have evidence of anything that happened before it. There could have been a whole populated universe and the Big Bang just hit the reset button. There's a theory that our own universe could end in another Big Bang type event too. Right now the universe is expanding, but one thing that might happen is that it switches to deflating. Gravities force the universe to collapse in a big crunch and we start over with another bang. Or our universe could just keep expanding indefinitely. The thing about this is that the edges of the universe aren't just spreading outward. The space between galaxies is actually expanding, like drawing dots on a balloon then inflating it. So we might just keep expanding until there aren't any galaxies close enough to detect. All evidence of the Big Bang would be lost and we would be essentially alone in the universe. Or another one is that organic molecules, carbohydrates, lipids, proteins, exist in space. They're just out there chilling. There's more stars in the observable universe than grains of sand on every beach on Earth. Works on the smaller scale too. There are more atoms in a single grain of sand than there are grains of sand on Earth. How huge it is. Just that, it's huge. Just the space between here and the moon is huge. You see that circle in the night sky? A circle so small it'll fit in a hole punch? That circle is thousands of miles across. It has to be dang far to look that small. And don't get me started on the sun. The expanding universe will increase in volume by 100 trillion cubic light years in the time it takes you to read this sentence. I read it really fast so it expanded less. Just remember that you're standing on a planet that's evolving and revolving at 900 miles an hour. It's orbiting at 19 miles a second, so it's reckoned. The sun that is the source of all our power. Now the sun, and you and me, and all the stars that we can see, are moving at a million miles a day. In the outer spiral arm, at 40,000 miles an hour, of a galaxy we call the Milky Way. Our galaxy itself contains 100 billion stars. It's 100,000 light years side to side. It bulges in the middle 16,000 light years thick, but out by us it's just 3,000 light years wide. We're 30,000 light years from galactic central point. We go round every 200 million years, and our galaxy itself is one of millions of billions. In this amazing and expanding universe, our universe itself keeps on expanding and expanding, in all of the directions it can whiz, as fast as it can go, at the speed of light, 12 million miles a minute, and that's the fastest speed there is. So remember, when you're feeling very small and insecure, how amazingly unlikely is your birth, and pray that there's intelligent life somewhere out in space, cause there's bugger all down here on Earth. The vacuum of space is -270 C, while absolute zero is -273 C. The 3-degree difference is due to residual background radiation, because thermal energy only transfers one of 3 ways. Your body would not freeze in deep space very quickly because the vacuum acts almost as an insulator. You would die from suffocation or go unconscious from the pressure difference before you froze. Things are constantly going out of view in regards to the observable universe. We can only see so far in space, but since the universe is expanding there are parts of it that we can see now, but as they're getting further away, they'll eventually get to where we can't see them. So the number of things in space we can look out and see is constantly getting smaller. You have been visited by the IT lizard. Upvote or experience bad internet for a month. Thanks for watching. If you are new to the channel, you can subscribe. I publish new videos every day. Until then, check another video, or don't. Either way, have a great day you magnificent people.